In this video, we are going to look at applications of exponential decay functions. Again, we start off with y equals a times base k to the exponent x. However, this time, the base k is decreasing, which means that it has to have a value between 0 and 1. So we write that as 0 is less than k, which is less than 1. So k is between 0 and 1. The other important thing to know about K is it is the amount that we keep. So just think of when you are shopping at a store and you find a shirt that's 20% off, you still have to pay 80%. So in this case, K would be 0.08 as a decimal. The exponent on the base, here it's x, is the number of time periods, just like it was for exponential growth. And then A is the initial amount, again, just like it was for exponential growth, how much you have to begin with. So let's look at the first question. Here we have Allison. She's buying a car for $30,000, and the car depreciates by 18% each year. So let's make let statements. So here we were talking about the amount of the car, and that depends on how old the car is. So the independent variable is going to be time, and the dependent variable is going to be the value of the car. So let V represent the value of the car, and let T represent the number of years, because it depreciates every year by this amount, 18%. So the value depends on T, so T is your independent variable X, and V is your dependent variable Y. And our initial value is 30,000. So that is our A. So A is 30,000. And to find K, we're going to use that 18%. So K is equal to 1 minus 0.18, which is 0.82. And I will explain that. The car depreciates by 18%. So it's keeping 82% of its value. So each year, it's 82% of what it was the year before. Again, we need to make that as a decimal. So you could work with the 18% first, subtract that from 100% to get 82% and change that to a decimal. Or you can change the 18% straight to a decimal and you take it away from 1, because 100% as a decimal is just 1. So K is equal to 0.82. So therefore our equation is V equals the initial amount, 30,000, times the K, the base, 0.82, to the exponent T. In part B, we are asked how much is the car worth in 3 years? So what is the value of the car? And the time period is 3 years. So it's going to depreciate 3 times in 3 years because it depreciates by 18% each year. So V equals 30,000, 0.82 to the exponent 3, and then just substitute that into your calculator. So you get an answer of $16,541.04. I left 2 decimal places as we're discussing money. In the second question, we are told that the half-life of strontium is 28 days, and you initially have a 50 gram sample. For those of you who have not heard of half-life before, it is the time required for a quantity to reduce to half of its initial value. So we often talk about half-life in terms of elements of the periodic table. When something is more radioactive, then it has a shorter half-life. An element that is very stable will have a much longer half-life. So let's define the variables. So we have the amount of strontium, which is dependent on how many half-lives have occurred. So I have written let A represent the amount of strontium and let N represent the number of half-lives. So I will say that A depends on N, so A is replacing Y and N is replacing X. Again, X or N that I've used in this case isn't the number of days, because the half-life doesn't change the amount every day. It's every 28 days. So I said let n represent the number of half-lives. You could have said let n represent the number of 28 days that occur. So next, let's find our initial amount, A. We are told there are 50 grams. So that means A is 50. And half-life means you are decreasing by half. So you are losing 50% of what you started with. So K, you start at 1 or 100% and you lose 50%. So when you lose 50%, you have 50% remaining. A simpler way is just thinking half-life, you're left with half of what you started with. So K is simply a half. So you can write half, or you can write 0.5. Remember, 0.5 is just half as a decimal. So whichever way makes sense to you. Just like when we, in the growth problems, when we doubled, we had a K value of 2. Here we're having a K value of a half. But this is the math behind it. You're losing 50%, so you are keeping 15% of that amount. So therefore, the equation becomes the amount is our initial value 50, and then you are going to multiply that by, and again, you can write a half or 0.5 to the n, where n represents the number of half-lives. So now let's use this equation. What is the mass on the 100th day? So we want to find the amount, and we have to substitute a value for n. So we have to figure out how many half-lives are going to occur in 100 days. So it takes 28 days to get to one half-life. So to figure out how many half-lives, we are going to take 100 days and we're going to divide that by 28. You get a decimal, 3.5714, and there's even more digits. Keep a lot of your decimals in your answer. I'll only round at the end. Another way of doing this is when you substitute into your equation, to keep accuracy, it's actually really good just to write 100 divided by 28 right in your equation. And then you don't have to worry about rounding properly and keeping a lot of decimals. When you do that, you might need to put the numerator and the denominator in brackets in your calculator. So using my calculator, I find that after 100 days, there are 4.2 grams left. In question 3, we are told that there is a translucent piece of glass that filters out 7.5% of light that passes through it for every 5 millimeters of thickness. So I just drew a little diagram to help you understand what this question is saying. But basically, you have a piece of glass. So I've drawn that here. And let's just say that that's a 5 millimeter thickness. So when you have light coming through that glass, before it enters the glass, we have 100% because you start at 100%. You lose a little bit of that light as it passes through that glass. And the question says you lose 7.5%. So when you take that away from 100%, you are left with 92.5%. So now let's look at this second piece of glass. I've doubled the thickness, so now it's 10 millimeters of thickness. So again, we will start off with the light coming through, that's 100%. When it goes through the first 5 millimeters of glass, it's going to lose 7.5%. The other way of looking at it, the better way of looking at it, is it keeps 92.5%. So as it passes through the first 5 millimeters, it still has 92.5%. Then as it passes through the next 5 millimeters, it loses 7.5% of the 92.5%. So again, it keeps 92.5% of the starting amount, which this time is 92.5%, which is 85.56%. So I may have lost you on the math of how you got this 85.56%, but that's what the equations are for. So once we set up the equation, you should be able to find this using your equation. But I just wanted you to understand what's happening. The light goes through the glass and it loses some of the light as it gets filtered out. So let's set up the variables. We have the amount of light and we have the thickness of the glass. So A represents the amount of light. That is our dependent variable. And then I said let n represent the number of times that the light passes through the 5 millimeters of glass. So it's not simply let n represent the thickness of the glass, and that is because we are told the percentage based on a 5 millimeter thickness, not a 1 millimeter thickness. So it's not per unit. So we basically need to find out how many times the glass is being filtered out at 7.5%. And that happens every time we pass through 5 millimeters. So now we need to identify our initial value, which is not given to us, but we're going to use 100% because that's the starting amount. We always start at 100% of something. Then our K value, we're going to get from using that 7.5. So K is equal to 1 take away 0.075, which is 0.925. So I took the 7.5, I changed it to a decimal by dividing by 100, and then because that's how much I'm losing, that's the percentage I'm losing or decaying by, I take that away from 1. So 1 represents 100% of the light, and the 92.5, or as a decimal, 0.925, represents how much of the light I have after passing through that 5 millimeters. So the equation is A equals 100 times the K, 0.925, and then to the exponent n. So part B asks what percentage of light remains after it passes through 24 millimeters of glass. So I want to know the amount A, and then to substitute n, I have 24 millimeters of glass, but it loses 7.5% after every 5 millimeters. So I need to figure out how many times 5 goes into 24, and that's 4.8 times. So that means the light is going to decrease by 7.5%, 4.8 times as it passes through that thickness of glass, the 24 millimeters of thickness. So now substitute into the equation 100.925. The exponent is 4.8. I didn't have to round. It was it rounded to 4.8 nicely. But again, you could put 24 over 5 as your exponent, and then just put that into your calculator. So in the end, after passing through 24 millimeters of glass, 69% of light remains.